Okay. Isotopes. These are atoms of the same elements, meaning they all have the same number of protons, but they have different number of neutrons. Okay. So let's look at carbon 12. This is the mass number. Carbon has a, let's look here. Carbon is 6, so it has 6 protons. So this carbon has 6 neutrons. This carbon has 7 neutrons. This carbon has 8 neutrons. Okay. And so to indicate this, we would write this. This C12 has this 12 as the atomic number. Number of neutrons would be 6. This would be 7. This would be 8. Okay. So let's look quickly at an example of me giving you atomic masses and stuff like that, and you trying to figure out how many protons, electrons, and neutrons we have. So determine numbers of protons, electrons, and neutrons for the following. For 2011 sodium, okay, this is my mass number. This is my atomic number. So this tells me how many protons I have. I have 11 protons. This is an atom. So number of protons is equal to the number of electrons. This tells me that how many protons plus neutrons I have. So this will be 20 minus 11, and this would be 9. Okay, let's look at 17 oxygen. Okay, 17, this is this plus number of protons. Protons for oxygen is 8. Number of electrons is also 8. And so this will be 17 minus 8, which would be 9. Okay, 9 neutrons again. C14, which we just did, C14, yeah. C has 6 and 6, because it's a neutral thing. And then 14 minus 6, it'll be 8. Okay, and then just to kind of finish this off, another isotope of sodium. These two are isotopes. Isotopes, same element, different number of neutrons. 11, 11. And this will be 22 minus 11, which is also 11. Okay, so now you should know what an isotope is, and you should be able to tell me, based on the atomic mass and the atomic number, how many neutrons, electrons, and protons you have for any neutral type of any neutral element. Okay. Let's look about the atomic weight and the molecular weight. So that mass number that we were talking about, right, on the periodic table, the larger one, that tells me how much this thing weighs, because the electron pretty much doesn't weigh anything. Okay, it is actually the way we get this is looking at all the available isotopes in the universe that we know of, and take the weighted average for that element. So we know for chlorine, for example, all the chlorine that's measured in the world, about 3/4 of it is chlorine 35, and about 1/4 of it is chlorine 37. Okay, I know that chlorine 35 weighs this, and chlorine 37 weighs this. I can take the weighted average, which is what's being done here, the weighted average, 75.58%, times the mass of chlorine 35 plus the rest. And this is how I get the atomic mass on the periodic table. So the periodic table, the reason you get these decimal points is because it's a weighted average of a bunch of different isotopes.